Okay, we are starting a new unit, so you'll have a new booklet of notes to work out of and a new booklet of independent practice. So we're in the graphing part 2 kind of booklet. So remember that you should be able to already graph these guys, right? These are our y equals mx plus b equations, right? So m is our slope, b is our y-intercept, and what we're going to do in this unit is we're going to add 2 more forms of a line, okay? And then we're also going to do some problem solving when it comes to distance and midpoint, and we're going to be doing a bunch of algebra, okay? So all of those are just kind of the big ideas of this unit. Okay, so we're going to add on to those things that we already know, and yeah, and kind of expand our concept of graphing linear functions. Okay, so let's get into some notes here. The first form that we're going to look at in this unit is called slope point form. Okay, and it looks a little bit scary. It's not scary, I promise, but it looks a little intimidating at the beginning, so just be patient here. All right, this is the structure for it. Okay, so we've got y minus y1 equals m bracket x minus x1, and we're going to close that bracket. Some things in here should look very familiar to you. M is the slope. Okay, and the thing that looks a little bit different is this x1, y1 business. So that looks, that's different. If we compare that to y equals mx plus b, which is our slope intercept, right? If we compare this y equals mx plus b to this structure here, we can see that this y matches up with that y, this x matches up with this x here, and instead of having a b, slope point has this y1 and this x1. So we don't know an intercept, okay? We don't know an intercept, but we do know a point the line passes through. Okay, now be careful, because the only thing that's tricky about this structure, and the one thing that students often forget, is they forget to notice the sign changes on x1 and y1. Okay, so what I mean by that is this point, this x value, and this y value in my ordered pair here, this point, the sign changes on them when I put them into this structure. Okay, so if that doesn't make any sense just yet, let's take a look at this example and see how it works. Okay, y minus 2 equals 1/3 x plus 4. Okay, how do I describe this? What's going on? Well, I think the easiest thing to find from this is this 1/3. What does this 1/3 match up with? It matches up with that m, right? So what does it tell us? It tells us m equals 1/3. Our slope is 1/3. Now, what about this 2 and this 4, right? This minus 2 and this positive 4. Well, they're a point. And remember that ordered pairs always have x first and then y, so we have to be really careful about where we put this 4 and this 2, and we have to change the signs. So we have a line, right? It's degree 1. It's a line. It has a slope of 1/3, and it passes through the point -4, +2. All right, okay, so now let's watch that. This x1 matches with this 4. But notice it's a negative x1, and this is a positive 4. So that means I have to change the sign when I put it into the ordered pair. Okay, and think about why that's the case, right? We don't want to write x minus negative 4. That looks weird, so we write x plus 4. Okay, so that's why this guy is a negative 4 in our ordered pair. And this negative 2 matches up with our structure up here of y minus y1. We have a y minus 2, so that means that y1 is 2. So that's where our 2 is there. And it looks like a negative 2 in our equation, but it's really a positive 2. Because again, we have to notice the sign changes here. Okay, so how do we graph this? Well, we want to plot this point first. When we were graphing y equals mx plus b lines, we started with b. We started by plotting that y-intercept, and then we found our next point, and our next point after that, from our slope. Well, here we're going to plot this point first, and then we're going to find our next point, and our point after that, with our slope. So, label our axes, have good scale, and then our first point is at when x is negative 4 and y is 2. There's our first point. Okay, and then we use our slope, rise of 1, run of 3, to get the next point. So rise 1, run 3, rise 1, run 3. I can go down 1, back 3, right? Same, same. And then use a ruler and connect the dots and put arrows on the end. Okay, and then notice I stretch that line out nice and long. None of these tiny little boring lines. Okay, so we plotted that point first, and then we got our next points from our slope. Okay, it looks very confusing, but I promise you it's not. Okay, let's kind of work in reverse now for the next problem. Let's write the equation for this line. Now, what I want you to realize when we look at this problem is we can't use y equals mx plus b. Okay, like not just because the whole lesson is about slope point form, but why is slope intercept form not a good strategy for us here, right? The question is, what feature of the line helped you decide slope point was the best structure to use? Well, this one, this is actually a question that would have shown up on your final exam this year, and it's so the reason we can't use slope intercept is because it's difficult to determine the y-intercept. Okay, the y-intercept is somewhere between -1 and -2. Okay, it's a little closer to -1 than -2, but we don't know what it is, and we have no way of guessing. We're not allowed to guess. This is math class. We're not guessing, right? We want to determine things. So because we can't determine what the y-intercept is, it's not a whole number or an integer. Okay, it's not on a grid line. We need to use slope point. So you're given, so here we are given 2 points on the line, right? But we only need to use 1 point. And it totally doesn't matter which one you use. Okay, and you know that the slope is going to be constant for this entire line. So once you determine the slope, then you can choose any other point that you know for sure is on the line to substitute. Okay, so let's figure that out. So we've got m is what? Well, from this point to this point, we have a rise of 1, 2, 3, and a run of 1, 2, 3, 4, and our line is going up. So I know my slope is positive 3 over 4. If my line was going down, I would have to make sure I had a negative there, right? And so now I've got some points. I've got 0.2, and I've got this point here, which is 3, 1. Okay, and I'll leave it up to you which one you choose. I'm going to write both of them down, but remember that both of them are exactly the same equation. Okay, and that's a little weird to kind of wrap your head around with right now too, but when we do a little bit of algebra later to turn these into other forms, you'll see that both of the lines that I'm going to write here are equal. Right? They represent the same line. So I can write y minus, well, if I put, this is my y1 here, this minus 2, I don't want to write y take away negative 2. I'm going to change the sign and write y plus 2 equals 3/4 bracket x, and I don't want to write minus 1 because that's going to look awkward, so I'm going to write plus 1. Okay, so this equation represents this line that passes through that point right there, and or I could use this point right here, the 3, 1, right, to write the equation of this line. So y minus 1, because that y value is positive in the bracket, in the ordered pair here, so I make it negative here, equals 3/4, because that's still the slope, bracket x minus 3, because I changed the sign from positive to negative. Okay, I hope that makes sense. Watch the video again if you need to. Also, do the practice work. Check your answers often in the back, and please let me know if you have any questions at all.